Hi there. In this video, we'll be giving a brief moment to each of these four components of calculus. Calculus is a very common subject to use for different things, and for that reason, and also the reason that it's very well understood, it's taught to people in high school and people in university. And we're going to see that calculus breaks down into four major ideas. The first of which is the idea of a function, and that the function is kind of the language that the rest of calculus builds on. So we'll see what a function is, and hopefully we'll see why it's such a good idea to know about. And then the second part of calculus is the main new thing that makes calculus what it is, and that's the limit. So we'll see what limits are and why they're such a great tool for doing things that couldn't otherwise be done. Just to give you a little hint, limits are about infinity. What happens if you do something over and 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 so on? What eventually happens? What happens if you keep getting closer and closer and closer and closer and closer to something, and so on? So limits are the way that we use infinity in order to do things that otherwise couldn't have been solved. And once we know what limits are, we can then talk about the two stars of calculus. Usually limits get kind of relegated to the bench, even though they're the ones that do most of the work, whereas derivatives and integrals tend to be the star players. Derivatives and integrals are opposites of one another. Usually people study derivatives first and then integrals, but and there's good reasons for that, but they kind of hold equal footing. So they're fundamentally different. Whereas functions form the language of calculus, limits are the key tool for calculus. Derivatives and integrals are kind of what you do after you've got the first two things understood. So just a quick word, what are derivatives? Derivatives are more or less about the question, how fast is something changing? How fast is it changing? How fast is it changing? Obviously that can apply to, tons of different stuff. How fast is the population of bacteria in this little petri dish growing? Or how fast is the amount of diversity in, say, the Amazon rainforest decreasing? Tons of different questions. Those are two questions from I guess you could say biology, but just imagine all the things out there that change. I mean, pretty much everything is changing. So anything that's changing gets tied into calculus through the idea of the derivative. The derivative being the answer to the question of how fast is it changing. So that obviously, at least to me, makes it obvious that calculus can be applied to pretty much everything. Okay, and now what about integrals? Integrals answer the question of how much has accumulated. This question also seems to apply to pretty much everything. Anytime that something is happening for a period of time, you can ask how much of something has grown over that period. That may have not have made much sense. So imagine you're walking along a pathway, and you keep picking up rocks as you're walking along that pathway. At the end, you can ask how many rocks have I picked up? How much has accumulated in my backpack? Or that's kind of a made up example, but another example would be over time your business has costs, and it also has revenues. So it's got money going out and money coming in, and you want to know how much costs have accumulated over this month, and how much revenue has come in over this month. So each day there's a little bit going out, a little bit coming in, and we want to know how much has accumulated over that period of time. So those are some examples that aren't from biology, but there's way more examples of derivatives and integrals than could ever be known by one person, unless maybe they spent their entire life just collecting examples. So in general, we've got something changing and something kind of growing over time, and we want to know about it. And that's what calculus sets out to study. And its two main players are derivatives and integrals, which are built on the idea of a limit. What makes a limit so powerful is that it's humans' way of using infinity to our advantage. And the whole story of calculus is told in the language of functions, which will be the first thing we talk about. And so that's a quick intro to what calculus is and why we might be interested in studying it. And that's all.